Previous lecture, we have discussed about the in previous class we have discussed about the hydropower dam, which we are supposed to use, in the peak load. So for that, the main thing is it requires geographical constraints. It requires two reservoirs. So normally a dam means one reservoir is enough, and but it requires two reservoirs. So otherwise we cannot satisfy the purpose of that meeting the peak load, because it is a pumped storage dam. So if so many people will get confused among these cascaded and the pumped storage dam, because in the cascaded case, so there will be number of reservoirs. Here also two reservoirs. So normally single reservoir. So if the people will think that if there is more than one reservoir, it may be the cascaded dam. So, but that is the different case. There we need so many reservoirs, and also the main difference is once we are going to release the water, we are not pumping it back. Okay, so these three cases are different. So normal dam is different, and pumped storage dam is different, and the cascade dam is different, and we will go through it detailedly in coming videos. That is the so there one is a generating mode, and the another is the pumping mode. So that's why it is called as the peak load dam. So if anybody asks, so why we are only meeting it, operating it to meet the peak load, because so during the pumping mode we are using the power again. So we are consuming the power. So it is a constant of the cost. So we will use it only during the peak load. So that is our previous lecture. So that is also almost working like a renewable energy. Here we will see the another type of alternative source of energy, that is the geothermal energy. So geothermal energy is also a conventional type of energy, and we can also say it is a type of renewable energy. So most of the people consider that so the renewable energies means wind and solar power, tidal energy. So hydropower, geothermal, and these things. See, anyway, this is a conventional. So this is not non-conventional. This is a conventional. So we have started it long back. So how this is going to happen? So the earth is having natural sources. So it is a natural source actually. So we are just making use of that steam which is generated already in the nature, in the underground. So how? So this is a rare thing which will happen in the underground of the earth. So normally what happens, the many people know. So during the rainfall, most of the rain it is going to the underground. So the water which is not going to underground will flow and it will form as a river, and ultimately majority of the rivers will go and join in the ocean. But the amount of water which is going and joining in the ocean is very very less when you compare with on the earth. It's very very less when you compare with the amount of water rivers flowing in the underground the earth, inside the earth. So because most of the water is absorbed by the earth, so there are so many rivers, there are so many ponds more than above the earth than the above the ground, uh, below the ground than above the ground. So in this, so if you say if it is forming like a river, so it is going, and again finally there also it will go and it will merge in the ocean, and some will form like a ponds, very big ponds, and during among these some the earth, uh, the lava, uh, the liquid which is inside the earth. So actually there is a big layer between this earth's crust where there is a molten rock or heat. It is in the molten stage. And to the ground now we are walking. So in between there is a medium which is formed of so many rocks. So in some cases of the in some places of the earth, it is very thin. In some cases, it is very nearer to the actual ground of the surface of the earth, and it is forming like a volcanic mountains, we know. But here, there are some places where this is nearer to the underground ponds. So this molten liquid is nearer, hot molten liquid is nearer to the underground ponds, so which is a rocky layer, which is formed in the rocky layer. So since it is very nearer to this pond in the rock layer of the earth, so it will get heated, and some cases if it is very nearer, it is converted into steam. So that is the actual background of the formation of the hot reserves. You can say hot wells or hot reserves. So these naturally formed hot wells we are using for our benefit of the production of the power. So this is the actual basic concept. So how we are getting the geo. So that's why we are telling geo means the earth, underground earth, thermal energy, the heat energy. So geo. So it is in the earth, and thermal. It is the heat energy. The heat energy which is coming uh, from the earth crust. We are able to use, we are able to tap, which due to the some natural geographical formings. So the geothermal resources are reservoirs of hot water that exist on or human made at varying temperatures and depths below the earth's surface. Okay, so it may be very uh, below, very low, or some cases it is very nearer to that surface. So that is that there are different types. Some cases it will be very nearer, and some cases it will be uh, very below to the surface of the earth. So if it is needed, we will make it some human arrangement. In some cases, there will not be any necessity for that. So wells, so reservoirs of hot water. So hot water, how it is? So in that rocky layer, normally the water will go and will move in the underground, and it will merge in the oceans. And some cases it is stored. So the water is absorbed by the ground. In some cases it is stored like, and it will be formed like a underground pond. Some cases it will be very big, and some cases maybe very small. So because of these things only, we are able to get the groundwater. Okay, we are utilizing so much of groundwater. So without these reservoirs, we cannot get this groundwater. Okay, so in some cases, so when this hot molten layer uh, is coming nearer to the surface of the earth because of the thin formation of this rocky layer. So it is coming nearer, and that stage, in that area only, if the reservoir is water reservoir is there, so this is coming nearer to the water reservoir, and it is supposed to, it is actually heating the water. Indirectly, it is heating the water. So that is the case. So wells ranging from a few feet to several miles deep can be drilled into underground reservoirs to tap steam, and very hot water can be brought to the surface for use in a variety of applications. So here if I am saying geothermal energy means not only for the uh, electrical application or power generation application, we can use it for uh, hot water utilization. So some cases we need hot water for bathing, hot water for washing. So in some cases we went to in the countries where the temperatures are very less, so room heating also we can use. So in industrial application also we can use. So but ranging from a few feet to several miles. So if that hot reservoir is very near to the surface, in some cases actually there will not be any need to uh, drill also. So it will be coming out like hot spring. So so many have listened hot springs. So some islands it will form in India also, some cases. So for cooking they will directly cook in that water also. So for cooking purpose also they will use it as a hot wells for, if temperature is bearable, they will use for um, uh, bathing purpose also, swimming like that. So, or if it is naturally farming like that, it's okay. Otherwise, we have to dig for some feet or some miles. So, with the new technology, we are able to find whether what is the below our feet. So, and it is used for the variety of applications. So, it is one of the example you can observe. So, it is a geothermal power plant. So, where we are using it for the application of the power. So, what is the application of the geothermal energy? So, generation of electricity. The first thing, actually, even the hydropower. Also, our first aim is to produce the power. So, generation of electricity is primary here. So, geothermal power plants are usually installed within a 2-mile radius of geothermal reserve. So, the radius will be generally 2 miles. The steam from this reservoir is either directly used to rotate the turbines of electric generator. So in the thermal power plant, which is going to rotate the turbine. So that is the steam. In hydropower plant, that is the water. In wind power plant, that is the wind. In tidal power plant, that is the tide. In the wave power, in the wave energy, that is the wave. Okay. So if you come to solar energy, we are not. So there is no need for turbine. So we are directly converting the photon energy into electricity. So here it is mechanical thing. So we need the turbine. So in the thermal power plant, we need a steam. Some energy, some moving force we need. Electromotive force. Some moving force is needed. So that is the to drive the turbine. So that is the steam. So here two things. That is, so the steam in the hot reservoir may be directly rotating the turbine. Or another thing, so we are using the hot water in the hot reservoir to produce the water, to produce the steam. So that we may directly take the steam from the reservoir, or we may use the hot water in the reservoir to heat the water, and that water will become, so the water which is not coming from the hot reservoir. So that is again made as a steam, and that steam will rotate. So this is indirect method. Okay. So, and also you can use it for the farming. In cold countries, geothermal energy is used to heat greenhouses or to heat water that is used for irrigation. So in cold countries, what will happen? So normal water uh, will get freeze. So so then we can use this type of hot reservoirs to melt this, to heat this water and use it for the farming also. So otherwise, so because of this snow, that total winter, we are supposed to stop the farming. And also this we are using in the greenhouses. We are using in the greenhouses. So next thing is industry. So geothermal energy is used in the industries for the purpose of food dehydration. So, so if you dehydrate the food, it will store for a more longer period. And also milk pasteurizing. This is also for storing purpose. If you are pasteurizing the milk, it will have more life. It will not get spoiled for more time. And also it is used for gold mining, like this extra. So many applications. So we are using hot water in so many applications. In the hospitals also we use the hot water to wash the wounds, all these things. Heating. So geothermal energy is used to heat buildings through district heating systems, in which hot water through springs is directly transported to the buildings through the pipe. So the hot springs are there since very lakhs of years actually. So we are just discovering them, and we are using for our application purposes. Okay. So the hot water from the springs is directly supplied to the buildings, transported to the buildings through the separate pipelines. So what is the advantage? So most of the times it is renewable. So it is renewable source. So you will, it's like a well. So if you take the water from the well, again water will be filled in the well. If you pump the water out from the well, normally it will get recharged. We have to say it recharged. So like that, these hot springs also, they are getting recharged. So you can say it is a renewable type of energy. So it is free, it is abundant. In some countries, it is really abundant. In some places, so this cannot be found everywhere. So and also it will not have any pollution. Okay. So the constant flow of heat from the earth make this resource inexhaustible. So It is inexhaustible and limitless to an estimated time span of 4 billion years. The heat in the Earth's crust cannot be lost. No, it will be lasting for 4 billion years. So, wherever this molten layer is coming nearer to the actual surface of the Earth, there we can also form artificial type of geothermal energy also. So next thing is green energy. So geothermal is non-polluting and environmental friendly, as no harmful gases are evolved with the use of geothermal energy, unlike the use of fossil fuels. So use of fossil fuels, everybody knows, it's continuous air pollution. It's a big thing of air pollution. So when compared to these things, this is really a green energy. It is not harmful. Even if you say the wind energy and thermal energy, so there also you are supposed to produce the products which are used, the solar panels. So how to dispose these solar panels, because most of the majority of the solar panel, we are using the plastic, and also the same case with the wind energy, that is wind turbine. So this is another case of polluting the earth. So in this case, there is no such type of things happening, and also no residue or byproduct is generated. So in thermal power plant, we will having so much of ash, fly ash, bottom ash, and also after so many cycles of circulating the water, we have to release that water again in the pond or in the river, which carries so much of impurities. It is very horrible in the case of the nuclear energy. It is very horrible in the case of the nuclear energy. So the disposing of that nuclear waste, radioactive waste, is a big problem. In some cases, even that is that may be utilized with high technology to again form a nuclear bomb. So it is a big issue. So such type of problems are not there in this geothermal energy. And also the generation of employment. So geothermal power plants are highly sophisticated and involve large scale research before installation. Okay, so first we have to find such type of hot springs. If it is coming out from the directly seen in the surface of the earth, it is okay. Then if you want to produce in the large scale, you have to search the place where that molten layer is very nearer to the surface of the earth. So this requires so much of research, actually, a large scale research before installations. Okay. So for this searching research, we need so much of human source. So it is creating employment. This generates employment for skilled and unskilled laborers. Okay. So skilled labor will be having some technology, and unskilled labor is guided by this skilled labor. So at a very large scale, at each stage of production and management. So even after installation, also for running this plant, you need skilled and unskilled laborers. So it is creating the employment, and again it is producing the power, and this power, based on this power, depending on this power, so many industries are established, and indirectly that industries will create the employment, and it can be directly used. In cold countries, geothermal energy is used directly for melting of ice. on the roads. So heating houses in winters, greenhouses, public baths. So hot water, okay, you can actually use for melting the roads. So the snow is a big problem in the cold countries. So this is going to somewhat relax that problem, solve that problem to some extent. So although the initial cost of the initial installation is very high, the cost for maintenance and repair is negligible. So the initial cost is high. So very good things with less pollution. The cases the initial cost is high. For initial cost of the hydropower is high, but there is no pollution. The initial cost of the thermal energy, that coal based power plant, is less, but pollution is high. And the initial cost of wind and solar energies are high, but pollution is very, very negligible. So like that. So good things of producing the power, less pollution, making power alternatives generally will have more initial installation cost. So when coming to the disadvantages, so what is the thing is, we cannot unlike fossil fuels. So fossil fuels, you can observe the coal, you can transport them. So the geothermal energy cannot be transported. So where there is availability of the geothermal energy, there only you have to install, like hydropower, where we can capture more amount catchment area, there you have to install. That is the major disadvantage. Once the tapped energy is harnessed, it can only be used efficiently in nearby areas. So if you transport also to very less distance, you can transport, because with the time it is going to get cooler and cooler it will become. So very limited distance you can transport, even if you transport also. Also with the transmission, there are chances of emission of toxic gases getting released in the atmosphere. If you transmit also, because of this hot thing, there is a chance of getting released in the atmosphere. And also the disadvantage is the high installation cost. The installation of geothermal power plants to get steam from deep under the earth requires a huge investment in terms of material and human. So if it is rarer and nearer to the earth surface, it is less. But it will sometimes we have to go some miles. So in that case, it is very costly project. So the intensive research. So before setting up a plant, intensive research is required. So because so if I go and if I dig and finally I am unable to find the hot reserve, so it is a big disaster. So it requires a intensive research. As the sites can run out of steam over time due to a drop in the temperature due to excessive or irregular supply of inlet water. So even if I find a hot reserve, in some times, in a period of time, the sources supplying water to this reservoir may disappear. So again, that reservoir may indirectly disappear. So this type of chance is there. So we have to research it deeply, because this type of thing should not happen after installing the power plant. So that's why the deep research is required, and which is costly. Limited to particular regions. The source of geothermal energy is available in limited regions. So some of which are highly inaccessible. So if it is actually in India also, it is there in Himalayas. So who will go to that very remote place and who are going to use this energy there, or we cannot transmit to the um, urban areas. So that is the problem. So if it is nearer to the human civilization, it will be useful. If it is very remote, then also it is not suggestible. Such as high-rise mountains, rocky terrains, which renders the process economically infeasible in many of the cases. So impact on the environment. Geothermal sites are present deep under the earth, so the process of drilling may result in the release of highly toxic gases. So actually, this will not have the gases, but when you are moving for this hot reserve, the path may have some toxic gases. So this is also a major disadvantage, and this requires so much of money and workforce. Okay, so this is about the geothermal energy advantages and disadvantages. So anyway, it is a good alternative for producing, good green alternative for producing the power. Thank you for listening.
Like, share and subscribe. Hit the bell icon for more updates.